Western Academy. Let's take a look at today's topic. We're looking at proportion and variation. Now, let's quickly look into proportion. When we've itemized or explained proportion in earlier stage, we've looked at proportion. We say when two things are proportional to each other, especially, for example, if they're directly proportional, when one quantity increases, the other quantity also increases, and if they're directly proportional. And if the one quantity decreases, the other quantity has to correspondingly decrease. So that's a direct proportion. But if it's inverse proportion, when one quantity increases, the other quantity has to decrease. Vice versa, like opposite in case of inverse proportion. But for direct proportion, one quantity increases with respect to the other quantity as it decreases also. So we do this in our everyday life. For example, if you increase the hours you put into your studies, probably you get to know better, you get to understand better, okay? You get to get better, right? You get to get better. So that's a direct proportion. Anything that increases, one quantity increases, the other one increases, then it's a direct proportion. We've explained that before. Now we can graphically illustrate that with this table. You can see this is a direct proportion of a function of y equal to 2x, meaning this is doubly for every value of x, y will double. For every value of x, you have to multiply by 2, you get the corresponding value of y. So when it's 0, we get 0. This is a direct proportion. When it becomes x is 1, this one increases. So it increases from the x increases from 0 to 1. You see y increases from 0 to 2, twice the value. Then x increases from 1 to 2, and then you see y increases from 2 to 4, twice the value. X increases to 3, this one doubles. So every time the value of x, the value of y will double. When we have 5 for x, the value of y will double. So this is a function of y equal to 2x, meaning it's a linear function. X and y are linearly related. Y doubles as x increases. For every corresponding value of x, y will multiply it by 2. The value of y will be multiplied by 2. We multiply x value by 2 to get the value of y. So this is a direct proportion or direct variation. Likewise, this second one. This one is a graph of y equal to 3x. So this is a graph of y equal to 3x. You can see here y is 0, x is 0, y is 0, x is 1, y is 3. So 3 times 1 is 3. Here 3 times 2 is 6. Here 3 times 3 is 9. Here 3 times 5 is 15. Here 3 times 10 is 30. So you can see the function y equal to 3x is the function for this proportion. So this is a direct proportion or direct variation. So when we say one quantity directly vary as the other, let's look at it schematically from a variation point of view. Let's take a look at it. Now, when one quantity, we say this is the symbol, y varies directly as x or as a multiple of 2x. Okay, we say y varies directly as x. Okay, let's look at it first from y varies directly as x. Now when we have variation, we want to remove the symbol of variation. We have to introduce what we call the constant of variation. Anytime we remove the symbol of variation, we have to introduce the constant of variation. So this becomes y equal to, when you bring equality to it, you make it bring mathematical equality to it, then you have to bring the constant k of variation. So this becomes y equal to kx. This becomes y equal to ks. Remember, this k is the constant value, which is 2. This k is the constant value 2 here. So 2 is the value of k for this function, okay? And 3 is the value of k for this function. 3 is the value of k for this function. So this is the representation. This is how we represent the function of variation, direct variation. When two things are directly proportional or that directly varies with one another, this is how we show the representation. We got likewise find a question to highlight that understanding. We can find a question to create an understanding for this concept that we just talked about. Now let's take a look at that. For example, if we say y varies directly as x, for example, I summarize it and make it easy. Question 1. If we say y varies directly as x, varies directly as x. Y varies directly as x. Now, if y equal to 7, if y is equal to 7 and x equal to 2, comma, x equal to 2, x equal to 2. Now, it says find y when x is 5. Find y when x equal to 5. When x equal to 5. So this is a similar questions that you can get from variation proportion or proportional similitude of this magnitude, of this nature. So if you have a question like this, say y varies directly as x. So we write it in symbol form. Y varies directly as x. If y equal to 7 and x equal to 2, find y when x equal to. So first and foremost, let's establish the function. Okay, let's establish the function. So you say y varies directly as x. That's the first sentence. So we put it in this format. Let's put it in this format. We say when we say in variation, when you introduce you remove the symbol of variation, you bring the constant of variation by introducing equality. Say y equal to, and the constant of variation is k. So you say y equal to kx. Okay, so this is the first knowledge we have. Now, you say if y equal to 7, so I replace y with 7. We replace y with 7 equal to kx. Now, k we don't know, so we put k. And x, in the first case, if y is 7, x is 2. So x is 2, so multiply by 2. Multiply by 2. So this is the first thing we get. So 7 equal to 7 on the left is equal to 2k. If you multiply this and this, 2 times k, it becomes 2k. Okay, we have 2k. 7 equal to 2k. So we can simply say 7 equal to 2k, so therefore, or 2k equal to 7, the same thing. 2k equal to 7. Now what is k? K will be equal to 7 divided by 2. 7 divided by 2. Right? K will be equal to 7 divided by 2. Which is 3.5. Right? So k equal to 3.5 or 3.5. 3.5. Okay, so now first and foremost, this is what we do in variation. You find the value of k first, and then you follow the second part of the sentence to find the value of y. Now you find the value of y because you already established the value of k. Now that you know the value of k, you can easily find the value of y, right? Now you know the value of k, we can easily find the value of y. You go back to the function by saying y equal to what? We've established an equation or an expression, y equal to kx. That's the expression that or equation that we have established. Okay, y equal to kx. This was the function we have established for this direct variation. So what you do here is to substitute. Now you know the value of k, you've calculated the value of k. So all you do is to substitute. So how do you do this? Find the value of y when x is 5. So we go to look for y, so I write y straight away equal to, we found the value of k, remember that, 3.5, or 7 over 2, it's up to you. So you say 3.5, which is the value of k, 3.5 multiplied by the value of x. They give you x when x is 5. So find the value of y when x is 5. So x is 5, you put 5 here. So 5 multiplied by 3.5, what will you get? 5 multiplied by 3.5, what will you get? 70.5. So this will give us 70.5, right? This will give us y equal to 17.5. So this is how we apply variation, direct variation to solve problem. This is how we apply direct variation to solve problems. Okay, this is how we apply direct variation to solve problems. Before we go further, or before we go to inverse variation, I think we should solve another problem, right? We should solve another problem with direct variation, at least 2 problems with direct variation before we go further. Now let's say question 2. If y varies as the square root, okay, of x, square root of x. Y varies as the square root of x. Now, if y equal to 12, if y equal to 12, when x equal to, when x equal to 36, when x equal to 36, find the value of y, full stop. Find the value of y when, mind you, we can ask you to find the value of x, not only find the value of y. So you just make x the subject. Find the value of y when x equal to 81. When x equal to 81. So this is another question on direct variation. The second example of direct variation. Okay. Now this is the second example of direct variation. Now let's take a look at this question quickly. So let's itemize, establish our function. We say y varies directly as the square root of x. So whenever we have a variation, the first thing we do is to remove so we say y is to remove the symbol of variation, and I introduce the constant of variation. So by removing the symbol means we introduce our equality so that it will become mathematically easy for us to evaluate. So we say when we remove this, we introduce the constant k square root x. So that's what we have now. This is what we're going to be working with. Y equal to k square root x. This is what we're going to be working with. These will be our functions or our equation that we'll be working with, right? These are relationship, direct relationship of y and x. This is the relationship, direct relationship between y and x. So this is the function we work with. So the first thing said, if y equal to 12, so we're going to start substitution straight away. If y equal to 12, or if y equal to 12, y equal to, if y equal to sorry, okay, let me erase this. Okay, let's erase this, and then now y equal to 12. Okay, let's use, which color can we use? Let's use this first. Y equal to 12. So in place of y, I'm going to put 12. So I put 12 here in place of y. then equal to, the first thing we do, we go to find k. You know, we go to find this k. And then we don't know k, so we write k down the way it is. And then the square root of, if y equal to 12, x equal to 36. So I'm going to put 36 here in place of x. So square root of 36 is what? 6, right? So I have 12 equal to k times 6, or 6 times k, which is 6k. Are you with me? 6k. Because the square root of 36 is 6. The square root of 36 is 6. 6 times k is 6k. So now to find k will be equal to 12. 12 divided by 2, divided by 6. K equal to 12 divided by 6. Meaning divide both sides by 6. That's just what I said. Okay? In other words, divide both sides by 6. If you divide here by 6, k will remain. If you divide the right side by 6, k will remain. If you divide the left side by 6, you have 12 divided by 6. That will give you 2. So k value is equal to 2. K value is equal to 2. Now let's find let's find y when x is equal to 81. So you come back to the function y equal to k root x. So now we know the value of k is 2, k square root x. So we know the value of k is 2. So we just substitute those values, and x is now 81. So we go to find the value of y now, because they say find y when the x is 81. So now we have y equal to the value of k, which is 2, the one we've obtained here. The value of k, which is 2, we can highlight it. Okay, the value of k is 2. So we say 2 multiplied by the square root of 81. So we first and foremost go to find the square root of 81. First and foremost, we go to find the square root of 81. First and foremost, we go to find the square root of 81. So the square root of 81 is what? 9, right? So we have y would be equal to 2 multiplied by 9. 2 multiplied by 9, because the square root of 81 is 9. So 2 multiplied by 9 will give us 18. So here, y will be equal to 18. Y will be equal to 18, 1/8. 1/8. That's the value of y. So that's what y will be when x equal to 81. Okay, so with these two examples, I think we've explained direct proportion, the direct one. Now it's time for us to go to the inverse proportion. It's time for us to go to the inverse proportion, right? So here we write inverse proportion. We write inverse proportion. Inverse variation. We can use them interchangeably, variation and proportion. Sometimes we use them interchangeably, okay? The inverse variation. Inverse variation. Okay. Now we just go straight to illustration. Inverse means the reciprocal function. Okay. So when we say y varies inversely as x, it's going to be like this. Y varies inversely means 1 all over x. Inverse relationship, you must put 1 all over. Okay, that's why we say like a reciprocal function. So when we say inverse variation, it means when y is increasing, s has to decrease. 1 all over is a decrease because it's an infraction. It's a decrease. When y is increasing, x has to decrease. If y is decreasing, s has to increase. That's the meaning of inverse variation. That's the meaning of inverse variation. One quantity, like for example, if your speed increases, the time to get to where you are going decreases. Speed and time, they are inversely related. If you increase, the more you speed up, the lesser time it takes to reach where you are going. Okay, with all factor, every other factor kept constant, the more you speed up, the lesser time it takes for you to go where you're going. Is that okay? So speed and time are inversely related. Okay, the more you increase the number of men to do your job, assuming they're working at the same rate, the lesser days or time it takes for them to finish. If you increase the number of workers, the lesser it takes to finish that job. If you have a piece of job for people to do, if you have a farmland to clear, the more you bring more people, assuming they are all working at the same rate, the lesser time it takes them to finish the work. This kind of relationship is called inverse proportion or inverse variation. Now let's take a look at the mathematical concept and solve one or two problems to illustrate this concept. Let's say y varies inversely as x, question 1. Y, let's say for inverse variation, we have the first question. We say y varies inversely as x, which means y varies inversely as x like this, and then we change it and introduce remove the symbol of variation and bring the constant of variation. So in doing that, this will become what? This will have this similitude. This will have this look. This will look this way. Y will become, you introduce equality sign, and then this time around you also introduce your k. You know, there's 1 in the numerator, k, so you say k times 1 all over your x value. Remember, k times 1 is always k, so this functionality will look this way. This whole expression will look this way, y equal to k over x. This whole function will look like this, y equal to k over x. So for inverse variation, this is how it looks, especially if y is inversely proportional to x. Especially if y is inversely proportional to x. So this function is what we're going to use. Okay, the question says if y is inversely proportional to x, then find if y is 5 and x is 3. You say if y is 5, if y equal to 5 and x equal to 3 and x equal to 3, then find y when x equal to 30. Find y when x equal to 30. Now let's come back to our function. They've given us the first value of y. Y is 5, x is 3. Let's find the value of k first. That's all we do first and foremost. That's all we do in the variation. Whether direct or inverse variation, the first and foremost thing to do is to first of all find the value of k, the value of your constant of variation. You have to find the value of k first, and then you now substitute, because there are usually two sets of values. The first set of value, they will give you your x and y so that you can find your k. The second set of value, they will give you only x. They will ask you to find y, or they will give you only y. They will ask you to find x. So whichever one, if they ask us to find x and they give us y, you just substitute it to this function. And if they give you x, they ask you to find y, you will just substitute it to the first function. First, you have to use this function to find your value of k first. That's the first thing. We use this function to find our value of k. So this is what it is. To find k, we say y is equal to k. Okay, k over, what's the value of x? Over 3. And remember, the value of y is what? 5. So we replace this one with 5. Let's erase this. And let's erase the y and put the value of y. The value of y is 5. So we put 5 there. Let's put 5 here. So the value of y is 5. So I put 5 in place of y. Okay? So, you know, this is all, if you want to put it in fractions, it will become 5 over 1. 5 whole number means 5 over 1 in fraction. So, to find k, we cross multiply. Why? Why do we have to cross multiply? Because we have equality sign. If here is plus, you cannot cross multiply. If here is times, you cannot cross multiply. Because this is equal to, between two fractions, you cross multiply to find k. Cross multiplication means you use the denominator of this one to multiply the numerator of this one, vice versa, and use the denominator of this to multiply the numerator of this one, vice versa. So k times 1, let's do this one first. K times 1 is k. K times 1, we get k. And then we do on the other side, the other cross diagonal, we say 3 times 5, we get 15. So our k value is 15. Our k value is 15. Is that okay? Now we established the k value. We've got here our k value. We can keep it. We're going to use it to find any other thing that they asked us to find. We're going to use this one to find any other thing that they've asked us to find. Like, for example, in this case, they asked us to find y when x is 30. So I'm looking for y now. Say y. Remember, y equal to k over x, right? This is the function. You always refer to this function that you use, y equal to k over x. So now they want you to find y when k is 15. We've calculated k to be 15. So y will be what? You put the value of k, which is 15, the value of k, which is 15, here, all over the value of what? X. When x is 30, they told us x is 30. So we put 30 here. So, okay, is that okay? So 50 over 30 is 1 all over 2. 50 divided by 50, you get 1. 30 divided by 50, you get 2. You get 1 all over 2 in fraction. Or you can put it in decimal, which is 0.5. You can put your answer in decimal, which is 0.5. Okay, you can put your answer in decimal, which is 0.5. Okay, so this is how we use it to solve inverse variation. Now let's take one more problem, the one that shows a lot. Okay, you see,
Okay.
I'm looking for, thinking of an inverse proportion for us to exploit. Is that okay? An inverse proportion for us to exploit. Okay. If y varies inversely as question 2 for this. If y varies inversely as 1 over s squared, okay, this is inverse variation functionality. So if y varies as 1 over s squared, find and y is 15, y is 15, and x is 24, x is 6, x is 6, find y okay, find y when x equal to 9. When x equal to 9. Okay, so like we said before, you have to find the value of k first every time. First of all, you derive your function. So this is going to be y equal to, when you introduce your equality, k times 1 is k. So this becomes k over s squared. This will be your function. y equal to k over x squared. So the first value is that y will be what? The first value is y is 50. So I put 50 here to find k. We don't know what k is. And x is 6. So since it's x squared, you say 6 squared. You say 6 squared. So 6 squared will be 36, right? 36 times 15. 36 times 15. 36 times 50, that's what we're going to have. So we have k will be equal to 30. If you cross multiply 50, because 6 squared is 6 times 6, which is 36. So it becomes 50 times 36. 50 times 36, that will give us a value of 540. K will be 540, right? That's our value of k. Now, what will be the value of x, of y, when x is 9? When x is 9, what will be the value of, when x is 9, what will be the value of y? So we say y equal to, we know the value of k now, so we put it there, 540 for the value of k, divide by 9 squared. 9 squared is 81, okay, divide by 9 squared, because x is 9 now. So 9 squared is 81. So you say y will be equal to 540 divided by 81. 540 divided by 81. Divided by 81. 540 divided by 81. What do you get? That will be equal to what? 540 divided by 81. That will be our value of y. That will be our value of y. 540 divided by 81. What do we get? Okay, we get 6.7, approximately 6.7. So that will be the value of y, approximately 6.7. This will be the value of our y. Okay, so this is how we do inverse variation. This is how we do direct variation and inverse variation. Okay, so I think we've come to the end of this section. Our next class will be on graph in practical situation, travel graph, conversion graph, and so on and so forth. Okay, so thank you very much. Thank you.